In this video, we'll be going over the bottom-up 1D array approach of distinct subsequences. So previously, in the 2D bottom-up approach, we can see that in each of the iteration, we are only relying on values from the rows I plus 1. This means we can use a single array to represent our 2D matrix. Let's go over the thought process. So in the 2D bottom-up approach, we can then, in each of the iteration, we can see that we are only relying on values from rows I plus 1. This means we can create a single array to represent our 2D matrix. Then in each of the iteration, each of the row iteration, we will be updating the values from the previous iteration. Let's go over the pseudocode. So right now I'm going to create an array subsequences to keep track of the number of subsequences. Then we're going to iterate through the indices from s.line to 0, denoted as I, basically keeping track of our current location inside s. Before this, we're going to create a variable, prev, to keep track of the previous value before we replace it. This is to keep track of the value at I plus 1 and j plus 1. So we're going to iterate through the indices from t.length to 0, denoted as j. Then if j is out of bound, this means we have found one possible subsequences. So before that, we're going to set previous to the current number of subsequences, which is subsequences j. And then we're going to set subsequence j to 1, basically saying we have found one possible subsequences. And then if I is out of bound, this means we have failed to find a subsequence. Before we set it to 0, we want to save the number of subsequences. Then we're going to set the number of subsequences to 0. Now before we replace the current number of subsequences, we're going to create a variable current and set it to the current number of subsequences. Basically save it before we replace it. And then in this case, we're trying to increment I and j by the subsequences I plus 1 and j. If we think of this as inside 2D matrix, this is the cell right below. Since we're representing the matrix as an array, we do not actually need to increment by subsequence I plus 1 anymore, because this value is going to be the same as this value. So we can just delete this. Now if the current character at I inside S is equal to the character at J inside T, we want to increment the number of subsequences by, if we move both pointers forward, at I plus 1 and J plus 1. And as we can see from this value is located at, if we think of it as a matrix, it's at the bottom and then I plus 1. So it's to the bottom and then a column to the right, which is the value before we have replaced it. Because don't forget, we iterate through from t.length to 0. This means we have already replaced this value, but before we have replaced this value, we have already saved it at previous. So we're going to increment the current number of subsequences by prev. Then we're going to set prev to current, basically saving the current value, the value at the current cell before we have replaced it. Then we're going to return the number of subsequences starting at 0. Then what's the time and space complexity? For the time complexity, it stays the same because we're still performing our nested for loop. And then our space complexity is of n, where n is the length of the second string, or in this case t. We can call it subsequences array. Now let's go over the code. So we're going to convert our 2D matrix into an array. Then we're going to iterate through the indices of s.length to 0, denoted as I, and then we'll create a variable prev to keep track of the previous value before we have replaced it, which basically the value at I plus 1 and j plus 1. And then we'll iterate through the indices of t, denoted as j. And then if j is out of bound, this means the number of subsequences we have found is equal to 1. But before we update the current value, we want to save it. and then we set it to 1, the number of subsequences. And in this case, we're doing something similar. If I is out of bound, this means we have failed to find a subsequence, but before we replace it, we want to save it into pref, and then set the current number of subsequences to 0. And now we want to create a variable current to keep track of the current number of subsequences before we replace it. And then in this case, we're trying to increment the current number of subsequences if we move I forward. But in this case, this cell here is equal to the current cell, so we do not need to increment anymore. We already have the value at the current cell. We can just delete this. Now, if the current two characters at the two indices are the same, we want to check the number of subsequences if we move both pointers forward. So in this case, we're trying to increment by the number of subsequences I plus 1 and j plus 1, which was the value at the previous value that we have replaced. And don't forget, we have saved it here, so we can just increment by pref. Then we can update pref to the current cell before we replaced it. See, we have saved it, and then we update the previous one here. And then we can return the number of subsequences starting at indices 0. Let me know if you have any questions in the comment section below.